This is the Amp Hour Podcast, recorded December 2nd, 2014. Episode 226, with guest Colin Karpfinger, Blendling, Bean, Brio.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble from Contextual Electronics.
And I'm Colin, the founder of Punch Through.
Hey, Cole. Thanks for joining us.
Welcome, Colin.
Yeah, happy to be here.
From sunny San Fran.
Rainy San Francisco today. Yeah, out of the ordinary.
Right. But Chris was just cheering that you were from the Midwest.
Yeah, I grew up in Milwaukee, Wisconsin, actually.
Milwaukee.
Yes.
The only thing I know about that is from Happy Days. Sorry.
We have a lot of beer. That's pretty much Milwaukee's claim to fame.
Right. And a giant-ass lake up there somewhere.
Yes, a lot of giant-ass lakes.
So you moved to where all the action is?
I did. Yeah, I went to school in Minneapolis, which is where our other office is. So we have an office in Minneapolis and San Francisco. And then I actually moved to San Francisco about 4 years ago. So I've been here for a little bit of time now.
But you did start the business where you
in
went
Minneapolis.
to school and grew up.
Yep. Yeah, I started it while I was going to school there. So I just kind of did a little bit of consulting when I had time, and it kind of grew. And one summer, I kind of spent the whole summer doing consulting, and it was just, I really loved it.
All right. So tell us about the light blue bean, which is your main product.
Yeah, the bean. So I guess at a high level, it's a great Bluetooth development board, and it's Arduino compatible. So you can kind of write Arduino code to do a lot of Bluetooth low energy things, like be an iBeacon or kind of read and write sensors. And really the most unique part of it is that it has no connectors. So there's no way, you actually can't plug it in. It's entirely wireless. So you can actually program it over BLE.
Cool. Then how do you connect stuff? It's got no connectors.
Oh, it has. So it has 8 points that you can solder. It's kind of like a proto board. You can solder things to.
Yeah.
So it has GPIO and two analog IO and so kind of the typical Arduino inputs, but then to your phone or computer, it's all Bluetooth.
And it runs a coin cell battery.
Yes. Yep.
How do you get that? What sort of life you get in from an Arduino? I assume you're not running the Arduino at full speed. Are you running it at a slower speed to get the battery life?
Good question. So we run it at 8 megahertz, which is kind of typical, but we also have a lot of function calls, and we put a lot of thought into putting the system to sleep.
Got it. Yep.
Yeah.
Yep. So you don't run the stock standard Arduino code.
Pretty much.
I guess. Because that just runs full pelt, doesn't it?
Yeah, exactly. Yeah. So you find very quickly that you have to use, bean.sleep instead of wait in your sketches.
Got it.
Yeah.
Yep.
Yeah, and it is funny, now power is so important that, running your, at mega going a few milliamps is just terrible. So, we've kind of designed the whole system to be low power so you actually can run on a coin cell.
Any thought about actually ditching the Arduino? Because it's not the lowest power environment. Any thought about coming up with a product that is super ultra low power, using like an MSP 430 or a Gecko or something like that?
Yeah, that's a really good question too. And we've developed
That's what we do here on the Amp Hour. We ask good questions.
Man, you guys are smart.
We think we might.
Sure. So
it's the illusion.
So we've done a lot of development with these other platforms that are low power. And the reason we chose to stick with the Atmega and kind of standard Arduino experience is just so that people who've already written code for these Arduino platforms can just use the bean without having to change anything. So it gives you this vanilla experience, which is actually pretty cool because if you consider that, you're adding all this Bluetooth low energy stuff, but really it feels just as if you're using, your typical Arduino.
Right.
Yeah, and we actually, we designed the system so that it actually has our other product on the Bean, which is the Bluetooth module. It's the LBM 313 module.
Okay. Yep, I've seen that. Yeah.
Yeah, and so that both kind of processors, the module and the Atmega, can put each other to sleep, and so you can have the module kind of forcibly tell the Arduino to go to sleep, or you can have the user code kind of say, hey, the user requested that we go to sleep. Let's, turn off.
Right. Because you might only have to, you might have an app where you only have to transmit once every, a single packet every hour or something like that. Right. But the micro has to run all the time or, vice versa.
Right. So in sketches where people are doing kind of data collection, the Atmega stays asleep, like you said, for an hour or something like that. And then the module kind of handles the connection to the iPhone and keeps that established.
This module you've got, this Bluetooth module, it's FCC certified. How much grief did you have to go to get it FCC for?
Yeah.
There's that laugh of I spent all my life doing that.
Right. A lot of gray hair now at the age of 27. We actually, I'd say we lucked out in that we had, we worked with a company in the Bay Area, and they actually had, some of their techs were really good. They're really not only smart people, but also, kind of a pleasure to talk to and be around, which is not the typical experience, I'd say.
Right.
So that made it a lot better. It's always kind of a pain in the ass, but we've done it several times, so we kind of understand it.
Does that mean that you had to start over? Is that the several times, or is this part of the consulting work? Is that the several times?
Part of the consulting work. Yeah. Yeah, and actually, so the only thing that it appeared that we failed on was when one of the test lab employees started classifying it as a Wi-Fi transmitter in one section of the test, and we just had no idea what he was asking about.
What?
I'm like, yeah, I searched the entire Bluetooth spec for this term that you're asking about, and I can't find it. I have no idea what you're asking me. And, it's almost like you ask these questions and it feels like either I'm going to be a total idiot and he's going to point out something that I just never knew, or it turns out that he's trying to classify it as a Wi-Fi transceiver.
Ultimately, how much time and money did it, if you want to talk money, how much time and money did it cost roughly to get a module like this certified?
Yeah. So,
ballpark.
The module actually has FCC, IC, CE, which is for Europe and Canada, and then we're actually working on KCC and MIC, which is for Korea and Japan.
Okay.
Yeah, so all of those, what we generally say, if you're comparing the development path of going chip down versus a module, we usually say that it costs about $40,000 and about 2 to 3 months to go through the certification for all of that.
Excellent ballpark. For those who want to,
and it'll vary based on your
their
test house.
Sometimes you should just buy the module, folks. Just
exactly.
Just grin and bear it, and hope Colin gives you a good price.
Right.
Well, was that an option? Was that a design option? When did you think, look, bugger it? Why do I own? There's companies out there that sell Bluetooth LE modules.
Yes. Yeah. We actually.
Is it a price competitive?
Yeah. So
thing?
part of our initial kind of product plan was actually for two parts. So a lot of our customers build things that are very small and price competitive in the market, and so we needed also a low cost solution for them. By kind of having these two products, the LBM 313 module and the Bean, we're able to kind of cover both the tens of thousands scale and the one scale. So it was we kind of planned on it from the beginning.
I really like it actually because it's it's like taking a consulting business, right? So you started as a consultant, and taking that consulting business and basically productizing it, because it's like, you're going to have people coming to you a lot and be like, I want a Bluetooth device, and now you basically say to them, well, you can't afford me, nor can you afford to spin something totally custom, but how about you put in this thing that we design and we can sell you for,
exactly.
What is it? What is the bean
and we'll
retail
sell you
for?
100,000 units.
Right. Sorry. What did you ask?
Sorry.
What is the bean retail for? Like,
the bean retail
module
is
as well.
$30.
Yeah. Okay.
The bean is $30. Getting down to about 26 in higher quantity, and then the module is anywhere between $7.80 and $10, depending on your scale.
How are you staying in business? Selling sub $10 modules. You're still doing consulting work?
You got to sell a lot of them.
Volume. That's how we make it. Yeah.
Like you were saying, when we launched the products, we already had a bunch of customers in our consulting customers.
Right.
And so we kind of knew what they wanted. We knew what they were looking for. So it made it just like you said, we're since we're a mostly self-funded company, we can't or rather, it was not as big of a risk because we knew that there was a demand for this kind of thing.
Basically you're designing your toolbox, right? That's the main thing.
Yep, so you didn't just have this great idea and go, oh, look, we'll go out and find a customer.
Right.
Which can fail miserably.
Yeah. Got to know there's a customer first.
Product names. You've got the light blue bean, cool name. The development board is the Vegas Lounge.
Yep.
Okay, I guess there's a story behind that. But then you went and called your bloody module the LBM 313.
Well, the LBM actually comes from light blue module. So light blue is kind of our Bluetooth Low Energy product suite. And we actually have an app on the App Store called Light Blue, which is like a general purpose test tool for anyone wanting to test their Bluetooth products.
Right.
Yeah, so that's the idea with that. Vegas Lounge is a story. So at some point, we decided that we wanted to name products and or revisions off of establishments that the punch-through team frequents. And one of those is this terrible karaoke bar in Minneapolis that I don't think any of us actually go to, but had a great name. So if you're in Minneapolis, I think it's in Northeast Minneapolis, you can go check out our office and then drive over to the Vegas Lounge.
Go there before the guys do.
Yeah. It's actually funny, going through all this FCC testing and everything. We're sending documentation around, and typically the boards are called something like Alpha 1 or something, and ours are like Vegas Lounge, and the techs are laughing at it, and but it's good. It's memorable. People definitely remember it.
Yeah, it's cool. I like it.
So what do you use the Vegas Lounge for?
Yeah, good question. The Vegas Lounge is it's kind of a full-featured development board for the module. So it really breaks out everything that you could use on the module. So it's whereas the Bean is like an easy entry point that gives you like a feature set that's easy to understand, the Vegas Lounge is like you can test anything on the module with this dev board.
Okay, cool.
So you can actually hack in there, measure supply current, and do all that sort of jazz.
Yeah, it actually has a current.
It does have a current sensor on there.
Yeah,
nice. Mm-hmm. Thought of everything.
Yeah, that's another big one. I mean, we used a lot of dev tools from these semiconductor companies, and as you probably know, they're often terrible. So we took a lot of what we didn't like about others and made one that we did like.
Yep.
I was actually pretty surprised about on the Bean. So like I have one. I don't think Dave, you haven't had a chance to play with one yet, right?
I do not have a Bean. No, I'm beanless.
But I was surprised that there's accelerometer on board. There's just stuff that's like, oh yeah, of course you put that on there. Tricolor LED, that kind of thing, and it's just like, but I didn't think about any of this stuff, and then that kind of just leads you right into some of the starter applications, especially stuff that might not be on like a lot of the beginner Arduino type stuff. So what was the real thinking behind putting an accelerometer on there as well?
Yeah, we we saw a lot of applications where you could do a lot with a small amount of hardware, and the cost added for putting something like that on the board is not terribly high. So we wanted to give you something that out of the box you could do a lot of stuff with, and a lot of kind of now you have more software developers getting into hardware, and it's really exciting for them to be able to take the bean and make something right away without having to solder or build any hardware necessarily. So you can make a motion detector and kind of control something with the gestures and just right out of the box.
Mm-hmm. Cool. Yeah, I saw your videos. Some of you guys had that video of you guys like running around your beach house, which was a little campy. But the one where you tack the accelerometer to the toilet seat, and then you tack the bean to the toilet seat, and hopefully you never reuse it for anything else.
That one didn't ship out to anyone.
Right. Yeah. And what have you got that in your backing of our crowdfunding campaign, right?
The lucky winner.
Yeah.
So tell us about the crowdfunding campaign, because you didn't use Kickstarter or Indiegogo. You rolled your own.
Right. Yeah. We wanted to try a couple new things, and we didn't see anything out there that really let us do that. And so, a lot of people think we kind of did that to save money, which really wasn't the case. I think, what Kickstarter and Indiegogo take is fair, but mainly the driver was we had this idea to drive sales where the first day of the campaign, the bean would sell for $18, and then it would kind of go up every day a little bit, ending at 24, which is like 20% off, I think. And so it would say, you go to the site and it would show you the price today and the price tomorrow. And we were, thinking that gives you a sense of urgency that you should just buy it now.
Right. And did it work?
It worked. I wish we could have a sample of not doing that to really compare. But our first day was huge. I think probably 60% of our sales came on the first day. Oh, so
nice. And how did you get that? Did you get blogged somewhere?
Yeah.
How did you get the publicity?
Yeah, we we just kind of put it out there as much as we could with any contacts we had, and we actually offered a lot of blogs a 1-hour exclusive window to kind of launch with it before anyone else could. Make Magazine took us up on that, and so they were ready to go at
Bingo,
9.
there's the huge audience right away.
Yeah, and then I think Gizmodo covered it later that day, and that was huge.
Checkmate.
Yeah.
So how many did you sell, and how much money did you raise?
Yeah, we sold, I think we raised almost $200,000, and we sold... That was somewhere around 8,000 units, 9,000 units.
Wow. Nice.
Oh, and actually, part of the reason I think that we were able to do that, we put a lot of thought into upselling people to 4 units. So the bean's cool. You can, since you don't have to plug it in, you can kind of build it into whatever you're making, and you don't have to take it out if you want to change something. So there actually is a reason to have more than one. But we kind of structured the buy page to kind of urge you to
entice them up the
yeah. And you got a free kit of sensors and stuff if you bought 4.
I got it if you bought 4.
Yeah.
Right. Yep.
I actually really like that too, because in the software dialogue, obviously that becomes a very big issue really quickly too, right? If you have you turn on, these things are always on, right? I mean, they're turned on by software. Yep. But if you had 10 of them in a room, now you don't get to see which cable you're plugged into. So there's just a function on there that says identify, and then that one actually lights up. And I know it's been years for me, right? I mean, I know it's been years with electronics, but like even I think because it's wireless and because it was I put it across the room and just clicking the identify, like that was even a little bit more magical than the Arduino Blink on test, right? Because it's like. Oh crap! This is magic. Yeah, obviously, yes. I understand RF. Blah blah blah. I get it, right? I know software stacks and stuff like that. But like, something about it still does it for me.
Yeah, it's that's cool. The other one, kind of like that, that we built in is, if you downloaded our app before you received your bean, when it actually got within range, since the battery, we ship with a battery already in the unit.
Right.
When the FedEx or UPS guy or whatever got to your front door and it was within range, your phone would actually pop up a notification.
Nice.
Yeah, so that was cool. And we were trying to say like it's so easy you can use it without even opening the box, and so that was cool. A lot of people liked that. A lot of people tweeted that right away, and that was really rewarding to see.
Pretty sweet.
Yeah.
So how is the ID done in these things? How is each unit ID'd and given a serial number?
Yeah. Good.
How does that work?
Yeah. For the user, it's generally done by name. So like in the loader, the loader app is the app that runs on the Mac or the iPhone or iPad or whatever, and you can rename them to whatever you want, and then that's you can sort them based on signal strength and see the name. And then
But how do you do that when you've ordered 10 boards and you've got 10 boards sitting there?
Yeah. So you
all
can
running and with their battery.
Yeah, right. You can write. So in one situation where the beans are acting as like an iBeacon or a beacon, you can actually assign them specific IDs. And so that's one way. And then there's a profile on the bean that allows you to kind of only see devices that are beans, but then to go kind of to find an individual one, you can either change the name or add a little bit of data to the advertising packet.
Right.
But generally we just wanted to, we didn't want users to like get into the state where they couldn't see them anymore. And so it's generally done based on name.
So what about, do these kind of devices, I know that like a lot of the, often you need to have like unique ID chips on like Ethernet devices. Do these have built-in unique IDs on the Bluetooth chip, or how does that work?
So it's a tough question, and part of the reason it's tough is that Apple will actually salt, I guess the ID, and so
salt.
So they
ruin it.
They like change. Yeah, they make it taste better. They change the ID so that you can't really track. You couldn't track anyone based on their Fitbit or something like that. So it's like a security choice that they made. And maybe I'll talk about later. Each like mobile OS vendor has their own kind of style of stack where they change some things around, and this is the one that Apple changed. That it's good for the users, but sometimes it's frustrating for the developers.
So they were doing this while they forgot to update the security on iCloud. Basically, they were salting IDs.
Yeah,
sorry, couldn't resist.
With that.
Yeah, that's weird, and that probably would get really frustrating for because then. So how do you guys actually go and you just kind of just pick them randomly then, and you just say whatever this ID is, you just hope it stays unique, or what?
No. So the thing that won't change is kind of the profile of the beans. So like our apps can tell which Bluetooth smart devices are beans, and that's always going to be the same. But generally, it's harder to know exactly which specific bean is yours, and the solution of that is kind of adding something in the application layer, so you can set an ID, and we actually have on the module there's a serial number that's burned into it, and that's pretty much unique.
Okay, yeah, right. That's good. Oh yeah, I see it here now. I guess that's the second line there.
Yeah,
I won't read mine on air.
Yep.
When you guys are handling that kind of stuff, then, so does that mean like on the Apple side of things, because you're using their Bluetooth stack, that basically you kind of just have to take whatever they're spitting out there? Is it kind of the idea?
Yes. Yes. But I'll say that actually there is a vast change in kind of Apple's policy towards external hardware for the better with Bluetooth Low Energy.
Okay.
So that's when Punch-Through started, I was developing a lot of products for the iPhone, but they'd have to plug in. So they had to go through this separate program called Made for iPod or Made for iPhone, MFI. And anyone who had to go through that kind of shares the same badge of honor of how terrible it was. And we actually sold our services based on, hey, we've done this, for 10 or so products. We know how to do it. Don't worry, we'll help you get through it. And I remember thinking maybe someday Apple will change this. And I didn't have faith in that. But with Bluetooth 4, Bluetooth Low Energy, whatever you want to call it, you don't have to go through that same hardware approval process. And so, you submit the app to get approved. And in the most extreme situation, they'll ask you for a video of your hardware working with the app, which is worlds different than it used to be.
Why are they such a pain in the ass?
There are a lot of people wondering that same thing.
Actually, but is it can you, at the end of it, did you kind of go, oh yeah, I can kind of see why they're being such a pain in the ass now, or do you still not get it?
I really still don't get it.
Get it right.
I think part of it was if you have things plugging into the iPhone, you really have a chance to change the user experience of the phone. If something is drawing too much current from the phone, it's going to kill the battery, and users will complain about that. Or maybe, it'll change the antenna characteristics of the cell antenna, and people will complain about that. So there's definitely reasons for it. But I think promoting this ecosystem of accessories to work with mobile phones is pretty important. So they finally kind of changed their tune on that.
And how did you go shipping your 8,000 odd products? Any dramas?
As far as the good stories, we had one catch that we right before a manufacturer in Korea started fabbing 8,000 boards, we figured out that basically the way we expected to wake up the module in hardware wasn't going to work. And so we had to, do this really scary thing of getting them on Skype saying, stop, 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 and then figuring out exactly how far they had gotten. And there's these weird situations where they may have etched, the bottom and not the top, and you may be able to get some really crazy solution in there by moving just one layer, but thank God, they hadn't started the boards yet, and so we were able to change it.
Oh goodness!
So they all went out. They no problems there, and we used a fulfillment center here in the Bay Area to do that. Yep. So we we shipped all the units over there, and then we actually went and toured the place mostly just to see what 8,000 beans would look like. Yeah. And
exactly,
it's funny with stuff. I was expecting. It's almost like you're expecting this giant, pallet stacked to the ceiling of boxes, and they're pretty small.
Yeah.
So it was still cool. But
so was that a worthwhile experience using such a company, or did it eat hugely into your profit margin?
No, I'm very happy that we did it. For a small company, I think we're not good at shipping. I think.
Well, especially that sort of volume. Like if it was a couple of hundred, you could do it yourself.
Right.
It's not a drama. You can slap on labels.
Right.
And, wander down to the post office. But yeah. 8,000 is a bit much.
No, I remember doing some previous things, and always thinking it'll be fine to kind of build or ship or whatever the first 1,000 or so. But no, I think it's great to use fulfillment center and kind of be ready for the next tier.
Right. But apart from that, you pretty much handled it all yourself in terms of did you buy it wasn't a turnkey solution, like one company just handled purchasing, manufacturing, testing,
right.
shipping.
This is what they do for a living, Dave.
Come on, man.
Yeah.
They're consultants. They consulted for themselves.
Exactly right.
So what aspects did you guys do yourself? Did you buy your own parts and then ship them to the assemblers?
Yeah.
Did you?
We basically did everything besides the component purchasing and the assembly and test. But we designed the kind of test procedure, which I'd say is like a big task that a lot of people leave out or don't expect to be its own task. So we did all that. We worked with our manufacturer to create this cool test jig. I think it tests. I think there's like 9 beans on one panel that come out from the assembly line, and then it actually tests all of them in one jig. So we have some cool videos of that and stuff. But
are those up on public? Can we have a
I think
look at those?
Yeah, they are. I believe we sent those out in one of our backer updates, but they're probably on our Vimeo channel. If you just go to vimeo.com/punchthrough, it should all be there.
Right. Because I'm sure there's a lot of people who want to know love seeing that sort of thing, want to know the ins and outs of how do you production test something.
Yeah.
Because it's
definitely.
Because if you haven't done it before, like you'll have no clue of the best way to do it or even the different methods to do it.
Right. And I would even say, understanding how the manufacturer wants to do it is important because like these guys don't have iPhones a lot of the time, and one of the previous products I worked on was this air guitar controller for the iPhone. It had an accelerometer in it. You could kind of play air guitar with your phone. And we made this great test app that was on an iPod Touch, and we had to supply iPod Touches to everyone in the factory. But we did some cool things you would it would actually time you testing each unit, and then you could get like a high score and put your name in and stuff. So we tried to gamify our testing. I don't think we didn't fool anyone, but
I'm just imagining this button down like test lab where then like you turn a corner and there's like, this gray haired dude just like wailing on an air guitar type of thing,
Yeah, pretty much.
No, I'm testing. Yeah. I'm testing, go away.
Yeah, well, we had to test each axis of the accelerometer because we had this bug where they were joining the plastic pieces with ultrasonic welding. And I learned that that's terrible for MEMS accelerometer. It's like it'll sometimes stick on one axis. And so, the test, you would just have to rotate it to the positive and negative, ends of each axis. And then when you got to the end and it had passed, an image on the screen switched to Homer Simpson and it had his voice going like, woohoo. So we had all these people on the assembly line going through this thing, and then Homer Simpson popping up, and I don't know. Who knows how much that translated.
That's cute the first time, man. But I think
exactly. No, if you've ever worked in a production facility and it goes beep, just going beep every time it passes a test, it just gets on your nerves, after the 10,000th year.
So we're actually torturing these poor assemblers with Homer Simpson.
Yeah. We used to have these etch machines at Samsung that would play like tunes when you're done, but like, you hear for release on a chip tune, 8 to 10 hours a day, and you just want to shoot yourself, it's just, or shoot Beethoven, Damn you!
Couldn't have been a little shorter.
Yeah, right, exactly. So on the manufacturing side of things, I'm curious. So the actual module that's separately manufactured from the bean, correct?
Correct.
So what are some of the challenges with? I mean, because this is like a super thin board. I've seen these type of modules before. With the metal can. Sorry, so people that haven't seen it, well, have pictures obviously, but there's a metal can. It looks like maybe the 20 mil board or something like that, and then a ballon on there. I mean, so what's the hard part about that stuff?
I'd say the hard part, I would say generally the RF, the RF characteristics. That's the harder part. Just because it requires some really expensive tools, and as everyone always says, it's kind of like a black magic thing. Like you don't really. There's so many parameters to the equations going into how it performs that you're really just tweaking things and trying to get the impedance to match, and so that's interesting. But it wasn't too bad, I'd say. Yeah. Generally, the RF stuff.
I
is
guess.
the tricky.
Yeah. I look at this. I mean, mostly because I'm looking at it, and the only real components that are showing outside the metal can. I'm not going to pop the can off this, obviously, but are like 0201 and maybe smaller. I can't tell.
Yeah.
But just like. I'm not used to that small either. Yeah,
totally. And actually, it's funny. The first few revs of the board, or maybe it's just the first rev we assembled ourselves here in our office. Oof. And, if you've ever complained about 0603, just try 0201s for a couple boards and you won't complain anymore.
We're going to need a bigger microscope.
Yeah. So, and it's funny, our first iteration of the module, we finished right before this company trip. So every year, all of us, we rent a house somewhere in California, and everyone comes out from Minneapolis or San Francisco, and we just kind of hack on some stuff for a week. And we had just finished like the first rev of our module and the first dev board right before this trip. So we're all, we think we're all ready. And we get down there, and within the first day, found a bug that killed 3 out of the 4 boards. And we actually, we hand soldered all the modules. We had hand soldered the modules to the board, and it was terrible. But now that they're assembled by professionals, and you have this nice thing like the bean to use, it's a lot nicer.
So how do you connect up to these things? You've got a bunch of square pads on the bottom, which I originally thought were, they're for production testing or something, but that looks like the only I/O on the thing.
Yep, that's how you attach it to your board. So it's really optimized for size, and so by putting the pads underneath.
So you just reflow square pads, so they're not like a ball array.
Right.
It's not like a ball-based system. It's just square pads. Then you just put your solder paste down and it reflows.
Yep. Yeah.
This is on the module you're talking about, Dave? Sorry,
the module.
I got a little lost here.
Okay, sorry. Yes, this is the module.
Yeah, so we're able to actually do it. Hobbyists can do it with a hot plate or a toaster oven or what have you. But it's a little harder to inspect, because you obviously can't see underneath it.
Well, it's practically impossible to inspect.
Yes.
Unless you've got an X-ray machine.
Right. So we've done that in a few cases, but generally, when you get the profile right and in production, it's not a problem. And
no, of course.
Yeah.
So, any thought given at the time to doing the half moon pads around the edge?
That's what we did initially.
Right.
Our first prototypes used that. Basically, we just wanted to get it smaller and be able to break out more pads.
Got it.
When you were designing the pad layout for that kind of thing too, what kind of considerations go into that? Because I've never done anything like that where it's a module with the pads underneath. I mean, is it basically just to get the pads as spread as possible, or does it not even matter because there's so few I/O kind of thing?
It's kind of an optimization between having enough room to route out all the traces. So like we on our site we have a couple example escape patterns that don't require any special PCB technology.
Right.
So it's just between that and having decent sized pads that will be reliably soldered.
But it means you've got to have a 4-layer board pretty much minimum with this, wouldn't it? You're like at least, no, you could route out 2 traces between pads, I'm guessing.
Yeah, yep, you can actually do a 2-layer board. Mm-hmm.
Okay, cool. Yep.
Yeah.
Any problems with, like if someone stuck this down to a 2-layer board in a product they wanted to make, and then, they had to go through what's that one? Don't you still have to do the non-intentional emitter type stuff, right? Yeah. You kind of have to do the end product approval, which is much faster and cheaper. Mm-hmm. But no, the bean is actually a 2-layer board. Oh, okay, that's good.
So it's made to be kind of cost optimized.
And are we allowed to say what sort of Bluetooth chipset you're using in there?
Yeah, it uses the TI.
Or is that secret source?
Nope. It's actually
it's out now, man.
It's in the part number of the Bluetooth module.
Oh, okay, right.
So 2540?
Yep, exactly.
Oh, okay. Yep.
That is a good chipset. And that's got what, like an 8051 on board or something like that?
Yeah. Yep. So it's just a really low power 8051. And it's kind of the most production ready part as far as like BLE components with also a processor on board.
Yeah, and there's a couple out there, right? I mean, because there's other chipsets that do BLE, but it's just about what was available. And I mean, how long ago did you guys start this kind of thing? Because I remember, I think I got a dev kit a couple years ago, but I never did anything with it.
Yeah, TI came out with it a couple of years ago, and really a lot of our BLE stuff kind of started when we got the dev kit, and there was no app on the App Store to test it out. The dev kit didn't come with any firmware, and so that was kind of one of the things that kind of made us think like, hey, there's an opportunity for some better tools here. And so there's a couple others on the market. It's still kind of in a lot of the production, a lot of the products out there, and it's pretty power efficient compared to other parts.
Have you had any supply issues with either the TI chip or the Arduino chip? Because I know there are supply issues with the Atmels.
Yeah. Our manufacturer is actually kind of like a partner with Atmel in Korea, and so they've been able to get them no problem, but I was a little concerned about that.
What about the TI parts? Are they easy to get in large volume?
Those have been fine. Yep.
Right. Because that's pretty much all you've got, right? I mean, well, there's going to be some passives and maybe some regulation on there or something, but
yeah, and the accelerometer.
Yeah.
Oh, you mean on the module or the bean?
Oh, I guess both. Yeah.
Yeah. So there's the accelerometer and RGB LED, but
apart from that, there's not much else.
Really? Yeah.
Yep.
So in terms of the actual the chipset, then do they give you the stack and everything you need for it then, or how does that kind of work then? Like
they do.
When you're starting to develop that.
Yeah. So TI has a stack that you get, and it comes with some pretty good features. A lot of the bean stuff, we've kind of added on to it. And so the whole system of the bean, kind of all the Bluetooth stuff is abstracted into the code we've written on the module, and then just the kind of user parts of it are on the bean in the kind of Atmel library.
And that stack, that's running on the 8051, right?
Yes, correct.
Do they give that in assembly or do they give it in C?
It's in C. There are a lot of parts that are pre-compiled. But it's kind of part of like a scheduler, and so you're able to kind of fit, your user code into it, so you're not, holding a connection or disconnecting.
Okay, so you didn't write all of this from scratch. You're sort of doing it at a more high level.
Yes.
Thing.
Yeah. Although there's a lot of like quirks that we kind of our protocol works around. So, for example, there's if you're interacting with the bean from a computer, from an iPhone or something. There's different endpoints. So you, like Chris was mentioning, you may want to just blink the LED and see which unit you're connected to. And so that message just goes to the module, and the LED is actually connected to the module. So that never has to interrupt anything the user code is doing.
Got it.
It's actually, it prevents against the user code on the Arduino kind of holding the LED, so it always can be overridden by the module.
Got it.
And so
that's smart.
The packets kind of know which endpoint they're going to, and you're never able to get it in a state where you can't connect to it and reprogram it, which took some work. And then you're also able to update the firmware on the module. So we actually counted the other day. I think we've released 12 new features in firmware since we shipped the pre-ordered units.
Oh, wow.
Excellent.
So we've been very, very active with that.
How does the module actually talk to the Atmega 328? Is it serial, or is there a SPI?
Yeah, it's through serial. Mm-hmm.
Okay.
And so it kind of interacts with the boot, there's a lot of commands that we've added, but then also when it reprograms it just kind of interacts through the bootloader like you would expect.
Okay. Yeah, what I'm mostly wondering about is, so say Dave or I were silly enough to think that we could do Bluetooth, and we bought a module and then wanted to interface it to something else. What are like the limits on the update rates, and I mean, can you do other protocols or anything like that when you're actually talking to other chips?
Yeah, you mean like if you want to interface like a SPI or I2C sensor or something like that?
Yeah. I mean, just basically when you're moving away from the bean and just using the module, how do you expect, or how have you seen people using this kind of thing?
I see. So actually, one thing that we're working with a lot of companies on is a way to take your code that you wrote on the Bean and move that into a production ready design. And so what you can actually do is use our module, our Bluetooth module, with the same Bean protocol, and then just add a different coprocessor, which could be an Mega, it could be an MSP 430, could be, ST Micropart, whatever. And that way, like, you can reuse the code generally that you wrote for the Bean, and also, have this system you can put on a custom board in any shape you want, and it's much more cost efficient.
That's great. That's like the promise of C without actually the realities of C, right?
Yeah.
Oh, I'll just compile my code again for a new processor. Yeah, right.
Yeah, exactly.
Good luck with that.
Yeah.
Now, you don't have any real-time clock on here, do you? To do, like, real-time tasks. As in,
is that what they're for?
Switch this on at 1 p.m.,
I've thought about that. There's some nice little modules or little add-on boards that could do that. Like one of the projects I actually made for fun with the Bean was this. Basically, it looks like a painting. It's on canvas. It's not actually. I did it in Photoshop. Don't tell anyone. But it has a bunch of NeoPixel LEDs behind it. And the painting actually shows like the California coast, and then it has each surf spot that I surf. So I surf a lot
right.
here. And so each, for the next 7 days for each spot, there's an LED that'll kind of tell me the condition for that day. And so and it's cool, except now it's great during the day, but then at night it's way too bright. And, so it's one of those things where you finally make it. You're like, oh, this is perfect, and then you're trying to go to sleep, and it's like super bright. Blue, Like, oh god,
Colin, time to get up.
Yeah,
time to go surfing.
Surf is good. Yeah, wake up. That wouldn't be so bad, but So I thought about adding like a real time clock for that, or maybe a light sensor would do it too.
Got it.
I mean, we don't expect you to tell us about your specific customers, but I mean, like, could you get us a feel for like, is it mostly software-based companies that are buying and using this kind of stuff? So that's why you're kind of guiding them towards this path, or is it more just people that need connectivity or that are maybe hardware people?
It's really all over the board, which makes it really exciting. Like, it's people anywhere from like teachers buying it to teach, students how to code. From, literally there's a guy that works at a middle school program all the way to like Carnegie Mellon. There's a professor there that's the Bean's part of their like connected device class. And then
nice.
Companies, it ranges from, startups with one person to Fortune 500 companies who have these kind of new like proof of concept departments that just crank out these new kind of prototypes. They're almost like a startup. So it's totally varied. And then, some of those people are going into production with that model where they use the module and a coprocessor. And that's kind of intended for people that are like, hey, we just want to get this out the door and build 1,000 or like 5,000, but we're, we can't quite see the path to like 100,000 yet. And then the guys a little bit above that, are using just the module. So like one of the companies I can talk about is this company called Misalu. It's an iPad music keyboard. So it's actually a Bluetooth keyboard that connects to your iPad, and you can play music with it. And it all works over Bluetooth Low Energy. It uses our module. Was funded on Kickstarter, and now they're shipping and kind of taking retail orders and stuff like that.
That's awesome. So I guess that's a good example too, because I'm wondering kind of about, like I mentioned, the update rate stuff as well. Mm-hmm. So is it like a MIDI style where it's like 32 kilohertz? Because MIDI is slow. That's what I'm always surprised by. Is like 32 kilohertz clock. That's all you get, but it's fine for most human-based tasks like that, right?
Yeah, and actually, the latency was their major challenge, which they overcame, but. Yeah, because the latency, the MIDI is definitely slow with the bandwidth, but it's fairly quick in terms of latency.
Because it's wired, usually.
Yeah, exactly.
Good old copper.
And then, so we're actually working with a company here in San Francisco called Retronyms. They make some really great music software for the iPad. Like one app is called Tabletop. And they're making this thing called Wedge, which is basically like a rubber stand for your iPad where you can plug in USB MIDI devices, and then it makes them Bluetooth MIDI devices.
Cool.
So instead of having this like nasty hub of wires and stuff, you can just make them all Bluetooth and kind of reuse your existing products. So they're using the module with a coprocessor, and actually it's unique in that they're allowing their users to change the code. So it's going to be open sourced. The like sketch that will run, basically power the product, is going to be open source, and so users could download that, change it, and then reprogram the Wedge using the Bean software.
So if you needed to like get rid of a couple of features or something like that to try and speed it up more, or what?
Yeah, well, and actually, so the Wedge has like a bunch of RGB LEDs, so you could write your own effects for like crazy light shows and stuff like that.
That's cool. So what about the latency stuff then? Like, so what is the overhead of the Bean just kind of out of the box? If I, just hit go on whatever, how long does it take to actually go to an LED on the Bean?
There are a bunch of factors that come to play here. A lot of them are iOS driven, or whatever mobile OS you're using, or desktop OS. So iOS imposes this minimum connection interval of 20 milliseconds. So that's always going to be your kind of driving factor on latency. So that's kind of the main one. And there's like a slight amount of latency for the Bean as far as communicating from the module to that mega, but that's on the order of like millisecond versus 20. So
right,
okay,
yeah.
So that's I guess what is the human? It's 30 milliseconds that is noticeable. Is that the one? I always forget. Yeah.
It's funny. This has actually evolved, I think, over time, because a lot of like touch screens, specifically iOS, there's always kind of a built-in latency that's a little bit longer. So it's kind of funny. I feel like people are becoming less attentive to this, but I think 30 to 50 milliseconds is when you really notice it.
Huh. That's interesting.
Although it's actually more perceptible, I think, when you're touching something and expecting a sound.
Yeah.
Oh.
Right.
Okay. Yep.
Yeah, I guess the human, the eye to hand to sound kind of, like if you're used to a piano hammer hitting, right? It's like that's a very well defined interval. But
yeah.
Huh. So let's talk about it, man. Let's bring it up finally. So Apple, what's so is this based on the stack being available, or why was it Apple first?
Yeah.
And what went into that?
Good question. So basically it's the stack. It's Apple saw this as part of their core feature set, and they really thought through a lot of features in the Bluetooth side. And as much as I'll criticize Apple for other things, they did a good job on this. And they actually did a funny thing where they disregarded the Bluetooth spec and actually added features that weren't in the Bluetooth spec, and now the Bluetooth SIG is actually adding them.
Because they're being forced to. They've had their arm twisted and they went,
right.
Okay, everyone's using them,
right.
bloody phone, we'll have to put it in.
Yeah, so exactly. On the iPhone, you can be central and peripheral at the same time.
Could you explain that? I don't know what that means. Sorry.
Definitely.
What does that mean?
Yeah. So Bluetooth Low Energy has two roles, central and peripheral. Typically, the small low power sensor device is the peripheral. It doesn't manage the connection. It just kind of does a minimum of answering to the central. So typically, the phone is the central.
So does that mean the peripheral can't just send out data anytime it wants? It's got to wait for a ping or something from the main device first?
The peripheral can notify the central that it has data, and then the data, then the central kind of reads it. So it can go two ways, but a lot of the more like managing the connection and stuff happens on the central.
Right.
So the iPhone can be both. You can write an app that scans for peripherals, or you can write an app that becomes a peripheral. So like in our Light Blue app, you can actually simulate hardware by advertising like you're a peripheral. And you can do both of those at the same time. So no one else did that. And now I think that's going to be in the 4.1 Bluetooth spec.
Got it. Interesting. And that's great too. I mean, that was really smart to make so you guys led with this app that kind of gave you the debugging capabilities, right?
Yeah. And that one's done really well for us. I think there's over 80,000 downloads of that.
Nice.
So, maybe not huge for a mainstream app, but
not for Angry Birds
developer.
Grandma's not downloading the light blue app, huh?
No.
Funny story about that, actually.
Oh, yeah? Okay.
She is now. Somehow Fitbit has recommended light blue as the official I lost my Fitbit, I need to find it app.
Oh, sweet.
And I guess, it's sweet in that they leave us 5-star reviews, but they also call us asking for support finding their Fitbit. So that's just funny. I don't know who decided to do that. But,
probably some developer who's used it.
So your app just sends out a ping, does it, and then tries to find where the Fitbit.
It just gives you, the signal strength of any Bluetooth device around you. And so, we have reviews that are like, oh, I lost my Fitbit in the sand at the volleyball court, and light blue helped me search for it for an hour, and I finally found it. And it's like, oh my god,
you guys are like the new version of the metal detector. Tell you, this hardware thing doesn't work out. That's where you go.
Exactly. We've just become an app company.
Detector.
That's it.
That's all you need.
Not this hardware business. Screw that. Let's just sell an app that finds stuff.
That's crazy.
Goodness.
So the stack is good, and I had heard that from other people. Actually, I had heard that when TI was, I think when they were starting to talk about their 2540 and pushing that in the marketplace, because they had asked if I wanted a dev board, and they're like, oh, but you need an iPhone. And I'm like, I'm not an iPhone guy, and I'm not spending $600 for one.
Yep.
And then I kind of asked around about it, and they're like, yeah, it's because the stack's good. So that makes a lot of sense.
Yeah, so we have some Android support. Like there's an SDK. It's kind of an unofficial SDK, but there are ways you can write an Android app that connects to the Bean, and the Bluetooth Low Energy support on Android has come a long way. Like as of 4.2, there was really no real way to do it. Like you'd have to use the manufacturer specific stack for each phone. 4.3 added it. So it's been getting better, and we've actually worked on products with Android. But, as far as being a small team, being mostly self-funded, we just had to focus on the platforms where the user experience would be the best. And then, when Android gets its act together, we can go do that.
I think it's really interesting, too, because we see this bit, and we've talked about it on the show as well, but like kind of seeing software people moving into the hardware space as well, right? I think that drives a lot of there are a lot of Mac users to start with, so that's interesting because then it kind of self-constrains your audience, and it's not like it's like a small group anymore either. But it's interesting because I think it just kind of starts to profile that. But then seeing that on we also see that on like the CAD side, we talk about that kind of stuff, and just seeing how it's changing the industry and how it doesn't matter as much as it used to, right? It's just. But I think the other interesting thing is that the fact that nobody said Windows yet, right? So we talked about Mac, we talked about iOS, and we talked about Android. Yeah. But I think about software development, and I think, okay, well, where's the Windows support? Or so
right. So we're actually working right now on a Windows loader app, and our choice for that was basically just like you said. People are writing software predominantly on Windows, and while we do want to allow people to write sketches on their Android phone at some point, having that as if you're a Windows and Android user and your only option is to use your phone, you might be kind of frustrated. So we want to cover the desktop side first and then do that. But, it's interesting. Like we're all pretty much, there's a lot of hardware guys here because, we do hardware, firmware, and software. And like you said, all the CAD tools are in Windows, and so we all have Macs, we all run Parallels, and just use our CAD stuff essentially in Windows. So
I think it's just really interesting good, bad, whatever. I don't think it's any of these things. I think it's just it's really interesting as a changing landscape because if you go back 5-10 years, and you just say, well, we're gonna not have a Windows tool. It's it's just like they would have been like, what are you doing? But now it's like that. Yeah, this makes sense, right? This definitely, and it's driven by the stack and the available software stuff. So I just think that's really interesting.
Right. Yeah, and it's actually funny talking about looking at this 10 years ago or something. So our app that we just released allows you to actually write sketches and program beans from your iPhone or iPad. And to do that, we couldn't put the compiler inside the app because Apple doesn't allow that. So it actually compiles on the cloud and returns on our server and returns the compiled hex and then programs over Bluetooth to the bean. So that explaining that to someone, that you're going to program this piece of hardware from your phone, it's going to compile on the cloud and then program over Bluetooth just sounds like a ridiculous thing, but it's really handy.
Yeah, don't worry, man. The Butterfly Net people are here to help you.
Yeah,
that's cool, and that's other platforms too, right? Like embeds move into the cloud type stuff, and we've, Dave and I have disparaged it in the past, but then it's kind of come a long way, I think, and it's really interesting because a lot of the stuff that people are doing is, at least starting with, I want to blink something, and then eventually it becomes, well, I'm blinking this thing, now I want to do this other stuff, and there's libraries available, and like, it just kind of all starts to fall together, and it makes a lot of sense.
Yeah, and the nice thing, the cloud compiler, you wouldn't notice that it's, you won't notice that it's in the cloud unless you don't have internet, obviously, but it's pretty, it's pretty quick.
So what is that like to... Do you? I can get it from an iPad because I guess you have keyboards attached to iPads. But like, are you doing a lot of iPhone stuff?
Yeah, good question. It seems kind of strange when you first think about it, especially for someone who's like been in software development for a while. But one thing it's really handy for is imagine you're giving a demo. You're up on stage or in front of some customers or something. And you're like, oh my God, my sensor threshold is wrong because this room's a little bit brighter or something. Well, you can pull out your phone and actually change that. So that's handy. It integrates with Dropbox, so you can still write most of your code, with your computer, and then just get it on your phone. And
that's cool.
Yeah, kind of the hidden value is that if companies, now that companies are making more hackable products, they can actually have different kind of programs that users are able to install or load onto their product over Bluetooth. So like, I talked about the Wedge product. You could have your friend write a cool like light sequencer effect. He could actually put that on your product from his phone.
Oh,
so
interesting.
That's kind of cool too.
So you're saying like, so it's like go navigate to this link using your iPhone. You tap a link. It pulls it to your Dropbox, loads it up, pushes it to your bean, and then now you can hook up your toilet sensor that you never did.
You've always wanted.
Never knew you wanted, yeah.
But then you can have it actually as part of an app as well. Then you're saying,
yes, could be just part of the app.
That's really interesting because if that becomes, I don't know actually. I guess like the Bluetooth devices that are out there now, like the Jawbones and the Fitbits and stuff like that, they also push firmware? I mean, do they have to be wired for that kind of stuff? Or
they push firmware, but it's not necessarily like user editable firmware,
Yeah. That's okay. That's really cool. I like that. That could be some interesting stuff.
We like to promote kind of products that you can modify, you can change, you can add features to. A lot more companies are doing that, and it's really great to see.
Yeah.
Nice.
That's awesome.
So you guys started out you started out originally as just a consultant doing this sort of stuff. And you branched in the harbour, and now you've got 13
people.
Yep. 13?
Yep.
Excellent. Are you still doing the consulting stuff? Or are you looking to get out of that business?
No, because a lot of our, like I said, the products kind of benefit the consulting customers so well that
right.
It makes sense to do both. But I'd say that more and more we're kind of working with companies who are doing stuff in our particular niche. So Bluetooth Low Energy or smartphone connected products is kind of where we're living these days.
Got it.
Yeah.
So have you got people dedicated to doing that sort of thing, or is it just, we've got a consulting job, all hands on deck?
It's kind of varied between the teams. So like there's no, everyone can work on different consulting projects depending on what we need, what skills we need. So everyone works on a variety of things. But I'd say, the last year we were pretty heavy on bean development, probably like, 60% of our effort. But now that it's pretty stable, we're bringing on more consulting projects and supporting that a little bit more.
Any plans to do like a standard header or anything like that in future versions? Or, I mean, I guess users could roll one real simple, but I guess if the punch through team has a standardized header, then is that something in the future as well?
You mean for like a connector on the board?
Yeah, I mean, or just a secondary version of the bean. I mean, is it going to just stay like this form factor for now, or are you guys going to keep doing other hardware stuff?
We really like this form factor. We've gotten a lot of feedback and we've seen how people are using it. So we don't really have anything that's public right now as far as different form factor. But we've seen people do interesting modifications. Like people have just made it smaller by chopping off the perf board essentially.
You're right.
Yeah.
So we may try to make that like a scored feature in the future. That's kind of the only one that will happen relatively soon. And then, we're just watching, we're watching where the connected devices are going and seeing how people use it. And we have a lot of thoughts there. So
there is a lot to be said for sticking with one form factor and not flooding the bloody market with 10 different versions of product.
Mm-hmm.
That's true.
So
we really, we tried to consolidate everything into kind of, one main product and especially for a small team, you have to focus on one thing.
Of course, you don't want to be supporting 10 different products. That's Do you guys find that it's more beneficial working in the same office, or do you get the impression that guys can all work from home and then come together using online tools?
That's definitely more common now, but I feel I still prefer to be in an office. I think there's chance encounters. You overhear someone talking about a cool project that relates to something that you're interested in, and that might happen on Slack or whatever you use for company chat. But I don't know. I just think it just feels better in an office. You share that enthusiasm and the culture. I don't think would be the same.
No, as a remote worker now, I can tell you it's a different experience. It's like when you're actually there with the people. Plus, I mean, I'm guessing if you guys are a San Francisco startup, you must have a beer fridge or something, right? It must like tweet or talk to your blue beans or something.
We just got a bigger beer fridge actually.
There we go.
Hit the nail on the head with that one.
Yep. I know. I'm learning San Francisco. I'm jealous of beer fridges everywhere.
So
are you guys hiring? If people want to join the dream.
Yeah, we are. We're always kind of looking for good people. And generally what I say is like we like people who are really excited by building things and, would do or did do engineering like projects outside of school without, being required to do it.
Well, look, if they're listening to the Amp Hour, they're a shoo-in anyway, aren't they?
Great point.
Right?
That's very good. True. No, and that's what I always look for when I'm hiring people too. I mean, that's the thing, and obviously Dave does too. So yeah. And it's interesting. I mean, interviewing is a tough thing, and I think I still have a lot to learn on it. But the thing that I've found is easiest is to have someone in, kind of just for a chat with another person that works at Punch Through and me, and we'll kind of talk around some things. And generally, if you talk about a project and someone's really enthusiastic engineer, they'll kind of chip in with their thoughts and, I worked on this other project that's similar. And it's really easy to tell just from a casual conversation like that.
Totally.
What you should do is you should lock them in the room, right? And then tell them that they have to access the bean and let themselves out, writing some code.
I hope they have an iPhone right now.
Yeah, exactly. Oh, bloody
no, Android user, huh?
No, they could write their own app.
Don't call us, we'll call you.
We just had an idea for something like that. It's still in the planning stages, but we want to put together a box of mystery components and basically just send it to a potential hire and say, hey, work on this for a max of 4 hours or something over the next week and make something cool and show us what you made. And
oh, that's great.
Put some useful stuff in there and put some totally crazy, ridiculous stuff in there and just see what they come out with.
Nice.
They used to do that for Boy Scouts. They would send us just like a box. It wasn't obviously technical stuff, but it was just like a box of junk, and then just like see what you make, right? And then you can see some awesome creations. So, no, that's great, man.
Yeah, I think we're gonna try that for students. Just it's a little bit easier, if they haven't been in the industry for a long time, just to get a sense of their creativity and stuff.
Send them make sure there's a Slinky in there or something, like something, some crazy stuff,
Yeah. One of our guys here had a lot of fun putting the list together. There's definitely some ridiculous.
For some reason,
there.
The first thing that popped in my head there was Egon Spengler from Ghostbusters. He said, "I had a Slinky once, but I straightened it." Sorry, it just popped in there.
That's a great one. Yeah,
that's good. So, Colin, how do they do that if they want to get in touch with you for the hiring stuff? Is it like an email address? Or?
Yeah. There's just info@punchthrough.com, which comes to a couple of us.
Okay.
Yeah.
Cool. Yeah, and portfolios are always probably a good thing to send
Definitely.
with that, I'm sure.
Yeah, we always say, we don't want to look at your resume. We just want to see the projects you've made.
Bingo. Awesome.
Nice. Yep. These guys know what they're doing, folks.
They do. That's good. Well, anything else, Dave? What else? I'm reinvigorated to go turn on the bean again and start programming it again.
I don't even have one.
No, you got to get one.
Oh, got to get one. Jeez.
You guys have distributors in Australia, right, Colin?
Yeah, and I'd say right now on Reddit and on our Bean Talk forum, we're giving away 10 beans on each site if just tell us a cool holiday project that you want to make, and the top 10 will get a free bean.
Well,
Sweet.
I can't tell you the project that I want to use this for, but I need it to... Basically, it ties in with my energy harvesting experiment video that I did. So I need to be
Colin,
able to...
If you could just send Dave a light blue bean and also a MacBook Pro, that would be very helpful as well.
Yeah, exactly.
Right.
No chance. All I need to know is how much current draw does it take when it transmits? And the answer's like 5 or 10 milliamps, right? Burst.
Yep. I think
current.
Yep.
Yeah.
For that short amount of time, I think it's about 10.
Damn it. Damn you, Bluetooth low energy. I'm going to have to go to something else, I think. It's just too high.
Can you get some good capacitors on there to buffer that out?
Yeah, but the issue is the charge time. Yeah, no problems. You can get a cap on there that can supply, your 10 milliamps for your 0.2 seconds it needs to transmit or something.
Yeah.
But, charging it up with energy harvesting is, But
you can actually scale, in software, you can scale the output power down.
Right.
So it's at like 4 dBm now, the highest, and you can scale it to like -8 or something like that.
Okay. Yep.
Yeah. So it'll be lower.
But still, it's going to take a few milliamps to pump it out, right? Yeah.
Yep.
Damn it.
You don't get enough sun there for that?
It's not, no, it's thermal energy. It's thermal energy. Solar's easy.
Cool.
Yeah. So,
that's really cool.
Too hard.
Maybe
I have to go to Ant or something like that.
Yeah.
One of those ultra low power, protocols. Because
good luck with the coding.
Yeah, exactly. Yeah, exactly. I have to do it from scratch. Won't be able to use a nice module like this. Probably. Grumble. Anyway, Cole, thanks for joining us. It's been awesome.
Yeah, thanks for having me. Yeah, enjoyed it.
People should definitely pick one up. They can go to punchthrough.com/bean and order there, or then I think there's some distributors around the web as well, right?
Yeah, definitely. Yep. Our site, Make Magazine, also sells it on the Maker Shed.
Cool.
Sweet.
Let us know what you make with it.
Definitely. All right, thanks, Colin.
Yeah, thanks, guys. That was great.
Thanks, mate. See ya.
Okay, bye. Oh, hold on. Sorry about that. Conference phone.
Conference room.
Oh, man.
Boards are finished testing.
Yeah. Yeah, it's Homer.